Hello, and welcome to the last chapter of the first semester. It's very short, and it's just kind of an introduction to it, so if you see it later on in your statistical career, you'll know what to do. Actually, today is the most important thing. Can you identify a binomial distribution? Binomial distribution, if you know anything about the prefix bi, it means two. Like bicycle. Bicycle has two. The biggest part of a binomial distribution is, number one, is that it has two options. They call it a success or a failure. And that's not always a success or failure. It just means one thing or the other. There's not three options or four. It's just two. A yes-no type of an idea. The other characteristics are a fixed number of observations. Maybe I'm going to go ask 100 people, do you like snow? Yes or no. So that has two options, yes or no, and I'm asking a fixed number of people. I'm not just asking so many people until I get enough that I want. I need to have a fixed number of people I'm going to talk to for this binomial distribution. 3 and 4 very much go together. Independent means one does not affect the other. Most of the time, that probably is true. If I'm asking people a question, I probably want to ask them by themselves, hey, do you like snow? Where one person does not influence the next person. More like, hey, class, would you like to have a test on Friday or would you like to have a test on Monday? People might have strong opinions about that. If I really want people to be independent thinkers, I would ask them by themselves, not just have them raise their hand in class. But it has to be independent. And 4, the probability of success never changes. Okay, your odds can't improve as things go along, and your probability of success can't go down. You can't get worse and worse and worse as we go. That is the problem. So today, all you're going to do is you're going to read a paragraph, and you're going to say, yes, it's binomial, or no, it's not binomial because it's not a fixed number of outcomes. So let's do 2 examples, and that's it. A pharmaceutical company claims that a new treatment is successful in reducing fever in more than 60% of cases. The treatment was tried on 40 randomly selected cases, and 11 were successful. Do you doubt the company's claim? Now, I don't really care about this. Let's check. Are there 2 options? Yes, it either reduces the fever or does not reduce the fever. Do we have a fixed number of people in this experiment? Yes, there were 40. Are they independent? I don't think one patient is going to affect another patient's fever level. 4, does the probability of success change? I don't think so. It's 60%, and it never changes. So yes, this is a binomial distribution. It's good. Let's check this one. New York City typically has rain on about 16% of days in the month of October. On average, how many days until you would expect it to rain first? So let's check. Are there 2 options? Yes, it either rains or it doesn't rain. Does one day affect another day? I don't know, but let's just assume independent. Does the probability of success change? It doesn't seem to. It seems to be 16%. This is the problem. How many days are we going to count? Well, it could be 1 day, and then it rains. It could be 14 days, and then it rains. I don't have a fixed number of observations. Okay, it could be this phrase, until you would expect. That's a dead giveaway that it is not binomial, because how many days am I looking at? Am I looking at 5? Am I looking at 12? I don't know. So this one is not binomial because it is not a fixed number of observations. Do I have a joke? I do have a joke. Do you know what is the hardest part of learning to ride a bike? The pavement. All right, that's it.